Good day. The topic we are discussing today is Sum of Arithmetic Progression 2 by Surat Olajumoke. This video is a continuation of the first video, Sum of Arithmetic Progression. In this video, the example listed in the video Sum of Arithmetic Progression will be solved. Topics such as arithmetic progression, especially the formula for its n term, the formula for its sum, its terminologies, and rule of logarithm must be known. Here, the first three examples are solved. Now, we move to the solution of these examples. So these are the examples. One is from the UTME 1990, one from UTME 1991, also one is from UTME 1987, and we have other questions to solve to buttress the points we made in the video Sum of Arithmetic Progression. Now we move to the solution of these examples. In the first question, we are given the first term A. We are given the number of terms, and we can obtain the common difference through the terms of the particular AP given. Since the sum of the first n terms of an arithmetic progression is given by this formula, S subscript n equals n over 2 multiplied by 2a plus n minus 1 multiplied by d. We all know this is the first formula for obtaining the sum of the first n term of an arithmetic progression, and we are using this formula because of the parameters given. We are given the first term, the number of terms, and the common difference. That is why we choose this formula out of the two formulas given. So now from the question, the first term is given as log A. We are asked to obtain the sum of the first 20 terms, which means n, which is the number of terms, will be equal to 20. And from the arithmetic progression given, the arithmetic progression is log A, log A squared, log A cubed. So from the terms of this particular arithmetic progression, we can obtain the value for the common difference. That is, the common difference is equal to subtracting the first term from the second term, which is equal to subtracting the second term from the third term. So here, the second term is log A squared, and the first term is log A. So it's either we have log A squared minus log A, which is the same thing as which will give the same result as obtaining log A cubed minus log A squared. So we prefer to choose this, and according to the rule of log A minus log B is the same thing as writing log into bracket A divided by B. So that is what we have here. Log A cubed minus log A squared will be equals to log A cubed divided by a squared. And according to the rule of indices, if you have a raised to power m divided by a raised to power n, is same thing as writing a raised to power m minus n. So a raised to power 3 divided by a raised to power 2 is same thing as writing a raised to power 3 minus 2. 3 minus 2 will give 1, that is a raised to power 1. So log a raised to power 1 is same thing as writing log a. So we've now obtained the value for the common difference, which is log a. So here we have the first term to be log a, the number of terms to be 20, and the common difference to be log a. So we substitute all this value into the formula for finding the sum of the first n term of an AP to obtain the sum of the first 20 terms of that particular AP. Substituting the values of a, d, and n into Sn, which is the sum of the first n terms, we have S20, since n equals 20, equals 20 over 2 into 2 log a, which is the value for the first term, plus 20n minus 1 log a, the value for the common difference. So 20 divided by 2 will give 10. We have 2 multiplied by log a is 2 log a. 20 minus 1 is 19. 19 log a. Following the rules of logarithm, that c log d is same thing as writing log d raised to power c. So we apply the rule here. 2 log a will same thing as writing log a squared plus 19 log a is same thing as writing log a raised to the power of 19, since it is a natural logarithm. So this implies that S20 here will be 10 into log a squared plus log a raised to the power 19. Also, according to the rule of indices, log a plus log b is same thing as writing log into brackets a multiplied by b. So log a squared plus log a raised to the power 19 is same thing as writing log a squared multiplied by a raised to the power 19, and that is what we have here. S20 is equals to 10 multiplied by log a squared multiplied by a raised to the power 19. So from the law of indices, a raised to the power m multiplied by a raised to the power n equals a raised to the power m plus n. So we apply the rule here. The sum of the first 20 terms of that particular arithmetic progression will be equals to 10 into brackets log a raised to the power our m is 2, our n is 19, so we have 2 plus 19, which will be equals to 10 log 2 plus 19 will give 21. So we have 10 log a raised to the power 21. Also, the rule of logarithm we've discussed before, that if you have c log d, is same thing as writing log d raised to the power c. So here 10 is c and a raised to the power 21 is d. So c log d is same thing as writing log a log d raised to the power c, which is a raised to the power 21. You know, if you have log 21, a raised to the power 21 raised to the power 10 is same thing as writing a raised to the power 21 multiplied by 10. And 21 multiplied by 10 will give 210, which will now be log a raised to the power 210. Here, so the sum of the first 20 terms of an arithmetic progression that has its first term to be log a, its second term to be log a squared, its third term to be log a cubed. So the sum of its 20 terms, of its first 20 terms, will be log a raised to power 210. So we'll move to the second question. Here, in this question, we were given the value for the first term, the value for the last term, and the value for the number of terms. So we are asked to find the sum of the first n terms. With the parameters given, we will know that we are to use the second formula for the sum of an arithmetic progression. That is, s subscript n equals n over 2 multiplied by a plus l. Since the parameter we are given is only the first and last term and the number of terms. So here in this example, the value for the first term a, which is the same thing as writing t1, is 7, and the value for the last term l, which is the same thing as writing t subscript n, is 117. And the number of terms in which the sum of that part in which we are to obtain its sum is 20. So now we substitute these parameters into the formula to be used. N is 20, S20 will be equal to 20 divided by 2 will be 20 divided by 2 multiplied by 7 plus 117. So 20 divided by 2 will give us 10, and 7 plus 117 will give 124. 10 multiplied by 124 will give 1240. Therefore, the sum of the first 20 terms of an arithmetic progression whose first term is 7 and last term is 117 is 1240. So we move to the third question. In the third question, let's see what the third question says. The third question says we should find the sum of the first 21 terms of this particular progression. So the first thing we are going to do is to determine if that particular arithmetic progression is that particular sequence is an arithmetic progression by checking if it has a unique common difference. So if it has a unique common difference, we obtain the value of that particular common difference, and then we proceed to finding the sum of its first 21 terms. So from the progression given, it is observed that it is an arithmetic progression, because if we subtract the first term from the second term, it's same thing as subtracting the second term from the third term. That is, the second term minus 8 minus 10, which is the first term, is equals to the third term minus 6 minus 8. So minus 8 minus multiplied by minus will give plus, minus 8 plus 10 will give 2, and minus 6 plus 8 will give 2. Since it has a unique common difference 2, then it is an arithmetic progression. it has a common difference, which is 2. Also, its first term, denoted as A, is minus 10. That is, D equals 2 and A equals minus 10. Since we are to find the first 21 terms, then we know that the value of n will be equals to 21. Substituting these parameters into the formula for obtaining the sum of the first n terms of an arithmetic progression, from the parameters given, we will be able to decide the formula to use for obtaining the sum. In this question, we are given the first term, A, the common difference, D, and the number of terms, N. So we know that we are going to use the first formula for obtaining the sum of a particular AP, which is S substrate N equals N over 2 multiplied by 2A plus N minus 1 multiplied by G. So substitute the parameters into this. We have S21, since the value of N is 21, equals 21 divided by 2 multiplied by 2 multiplied by A, which is minus 10, plus N21, subtract 1 from it, and you multiply it by 2. So we evaluate this. We have S21 equals 21 over 2. 2 multiplied by minus 10 will give minus 20, plus 21 minus 1 will give 20, multiplied by the common difference 2, which is also equals to 21 over 2 into brackets minus 20 plus 20 multiplied by 2 will give 40. Minus 20 plus 40 will give 20. That is how we have 21 over 2 multiplied by 20. So we multiply 2 here 1, 2 here 10. 21 multiplied by 10 will give 210. Hence, the sum of the first 21 terms of the progression minus 10, minus 8, minus 6, which we discovered that it is an arithmetic progression, is 210. We will stop the solution of the examples here. The next video will be on the solution of the remaining examples, that is example 4, 5, and 6. Next video will be more on sum of arithmetic progressions with sample questions and solutions. Please subscribe to our YouTube channel, like and share our videos. Thank you.